The U.S. space program has invested decades of intensive and expensive research to give us a fundamental understanding of what the planets of our solar system are composed of. Mars has been a logical target for that. Its proximity, the possibility that it had habitable environments in the past, and of course the kind of the collective imagination of our society about Mars all led to making Mars an important early target. The first information that NASA retrieved was from a group of what we call Flybys satellites. These are small robots, about 1/2 ton in size. They don't go into orbit, but they brush through the outer portions of the near proximity of the planet, and they take a group of pictures. So NASA launched the Mariner 3 and the Mariner 4. Mariner 3 unfortunately exploded. The top of it came off and it didn't reach Mars. But Mariner 4 was very successful. It reached Mars and it took a whole series of black and white images. Now for modern day standards, these images are very coarse-grained, they're crude, they don't give us a whole lot of information that we really want at a high resolution. But for that time period, they were remarkable. And they revolutionized our idea of how the surface of Mars has been formed and what it's composed of. Another thing that was really important about the Mariner spacecraft is that Mariner 5, which followed the success of the photography of the Martian surface by Mariner 4, Mariner 5, its target was actually Venus. And as Mariner 5 was passing Mariner 4, they were able to negotiate and interact in terms of communicating back with Earth. And so Mariner 4 also helped with exploration of other planets as well. But that combination of the Mariner satellites also provided us not only with black and white pictures of the surface of these planets, but it also gave us fundamental understandings of what the solar system is composed of. And one of the most important of those was solar wind. The surface of the sun is constantly emitting high energy from its surface, and that propagates through the space away from it. And it makes what we call a solar wind. It showers all the rest of the solar system with this energy. And the thing that protects planet Earth is the fact that we have a magnetic field. And that magnetic field acts like an umbrella to shelter us from that solar wind. Well, the next group of spacecraft that were really important for advancing our knowledge of Mars, there were other flybys and there were other orbiters. That's the idea of putting a satellite actually into a permanent orbit around the planet, was the 2001 Odyssey. And the Odyssey satellite revolutionized again our understanding of the surface of Mars. That satellite had a suite of high-resolution cameras that gave us black and white and color images of the surface. And it provided images that were extremely high resolution and gave us the information about the topography, the surface features, the surface structures that Mars was composed of. And there we got information about the magnitude of some of the features on Mars, the geomorphology that have been formed through geological time. And we'll talk about those in just a moment, about some of the drastic and amazing features that we saw. So the Odyssey, which is still operating, revolutionized our ability to understand the planet. Now, there are many things that the Odyssey provided, but one of the most striking was the idea of polar geysers. And so in black and white imagery, the Odyssey was able to show that there are almost these spider-like dark veins that run, and that those veins connect together into central points that is shown on this image. And, the idea there was, well, what can form that kind of a spider-like network of line-like features that are connecting into central points? An artist's rendition is showing nicely that actually what has been proven is that these are polar geysers. These are where we have gases that are emitted from the polar ice sheets on Mars, and they erupt like a geyser does, and then it spreads ejected material and sediments away from that. It makes that kind of anastomizing spider-like network of features. So polar geysers have been an important aspect of our understanding of Mars. Another one is that we were that NASA and the U.S. space program have been very focused on, is there water on Mars? The search for life includes the search for water, the search for nutrients, and the search for the chemical components that make up life, the fundamental building blocks of life. And tracking the water has long been thought to be the way to track the distribution of life. Well, the Odyssey provided us with amazing photography of stratigraphic sedimentological features on the planet that could only have been formed by large, vast reservoirs of water, not so dissimilar from what we have on Earth itself. So in this imagery, we can see that this is at the lower flank of one of the larger volcanoes that occur on Mars. And that volcano, it erupted molten rock on the surface, and that lava formed what we call a dike. It's a wall of lava that solidifies and becomes a solid wall of rock. And that wall of rock was breached by water. And we can see that from the water cutting a valley through that dike of molten rock. Another thing that we see very commonly throughout many areas on Mars' surface are flow streams. In other words, when flowing water is moving across the surface and moving sediments and carving its way into the landscape, it leaves flow patterns. And we can see from this image that there are very distinct flow patterns. So the Odyssey really confirmed for us the idea that there was very abundant amounts of water on Mars. Another thing that the Odyssey provided for us was the absolutely remarkable magnitude of the scale and the size of some of the geomorphic and geological features on the planet. The largest canyon that occurs on Mars is actually as large as the distance across all of North America from San Francisco to New York. And so we know that in Arizona in North America, we have the Grand Canyon, and that's an extremely large canyon. It's a mile deep and it's very extensive, many miles in length. But this would have been something on the order of thousands of miles in length. And again, we don't have features like this on planet Earth. And this imagery is so striking because also it shows very nicely that as the canyon is being carved, much of that had to have been carved by flowing water itself. So the combination of the flybys and the orbiter imagery has given us the template of information that we've needed now to move forward and launch on-the-ground missions on Mars as a preemptive strategy to prepare for eventual human missions that occur on Mars. In this image, we see these gigantic Arabian-scale sand dunes that are marching across the landscape to the lower flank of one of the larger, again, volcanoes that occur on the surface of Mars. And this kind of high-resolution imagery therefore gives us the base map that we need to move forward to plan missions, to know what the distribution of elements and geological features are on the planet. And with that combination of topography and geology and geochemistry, then the decisions could be made to launch the missions that we are now involved with, where we put rovers and landers on the ground that are communicating with the orbiters themselves. And the summary of all this is that the flybys and the orbiters have provided us with a comprehensive map of the surface of Mars, and that map lays the groundwork then for the ongoing and future missions of the U.S. space program.